Hey, Garrett.
Hey, Sparks.
How are you?
I have pretty bad allergies today, actually.
You know what? I've got them too. I woke up sneezing my first math lab this morning. I sneezed a good bit all the way through it. It's awful. I
Yeah, I
think
can't
the
wait.
weather being cold and then warm all the time is making it crazy.
Yeah, like yesterday, my throat was just kind of a little itchy, but I like today it was awful.
Ugh. My head's killing me. I have that sinus pressure thing going.
Also, I think a delay. I can hear myself talking like right after I fart.
Oh, I hate that. I'm sorry. I don't know if you want to get off and try again or if you just want to talk as little as possible. And do you want me to do all of them or do three or four in each section?
I like to do all of them.
Okay. Um, have you tried any
No,
by
I
chance?
just saw
Or
notification.
are you totally confused?
I have never touched this before.
Okay. All right. Okay. Um, I don't know. I probably should have. I know that she sent y'all the copy of the notes. So I'm thinking, hang on just a second. I'm thinking that I'm gonna well, talk a little bit, like connect with the notes a little bit, and then talk about how I got what I got when I get the answer so that hopefully you'll understand it better. Um, okay. So the notes that she handed out basically have this written on them, and it's kind of giving you an overview of what the reciprocal function looks like, both algebraically over here, um, and then kind of the breakdown of its shape and all of that over to the right. And the domain is stated like basically what this is. It's x, and then this straight up and down line, that means x such that x cannot equal 0. So that's all that means. It's like every number in the whole wide world except for 0. And the whole reason for that, and this is the main thing that you want to get about both the vertical asymptote and the domain, is the whole reason that it can't equal 0 is because if it did, 0 would be in the denominator, and you cannot have a 0 in the denominator, period. Can't divide by 0, can't have a 0 in the denominator of a fraction. And so being the case that the reciprocal function is basically, the reciprocal means if we had x, the reciprocal, it's x over 1 is stated as a fraction. So the reciprocal of that is 1 over x. So that's where the word reciprocal comes from, okay? But you cannot have a 0 in the denominator. The other things that you want to know way back from the parent functions, H and K are showing back up, and they are where your graph is going to shift left and right horizontally is H. And it's always opposite because the original format is X minus H. So if you have X minus a minus H, that turns into X plus H. So if it shifts left, that's going to be in the negative direction. But it's positive when it appears in the algebra. And if it's negative, it goes right. The vertical shifts up and down, positive, negative, they make total sense. If A, which is this part up here, if that is negative, instead of being like this, it's going to show up like this. if A is negative. And then if the absolute value, and the reason for that is because the negative is what reflects it across the x-axis. If it is greater than 1, it's going to be a vertical stretch, which just means it's going to be a little fatter this way. It gets further away from these things called asymptotes, which means they just don't touch. And if it's a compression, which means it's going to be less than, which actually will be a fraction out front, it's going to be difficult to draw this because I don't think on hers you can't get much closer, but you would actually be compressed closer to the asymptotes, like pushed in. So I kind of wanted to talk about that a little bit before we went on to the other. So given what I just said, f of x equals, if it's translated 2 units left, now first of all, we know it's going to be a fraction. If it's translated left, that means it's going to be going in the negative direction. So that would be a minus 2, which technically is plus. And there's no A because it's not saying that it's stretched or compressed. So your 1's going to go there. And then it's going down. So it's minus 9. So this part is the only part that is a little funky in the fact that it's opposite. Does that make sense?
Yeah.
Okay. So I think we had opposite stuff earlier when we did parent functions as well. So this one is going to be reflected across the x-axis. So we know that that top part is going to be negative. Then it's going to be translated up. I'm not going to make my fraction bar quite so big. Translated up 5. But that's all the changes in it. So I've marked the reflection by giving a negative. And it's only going up. It's not being shifted left or right. So that's all you're going to do. Oh, and the other thing I forgot to do, I was supposed to write down the asymptotes. The asymptote for number 1 is, the vertical asymptote is x equals negative 2. And the horizontal asymptote is y equals negative 9. And on this one, the vertical asymptote, this is anything, 0 can't be in the denominator. So what would ever make the denominator 0? And in this case, it would be 0. It can't be that. That's the vertical asymptote. And the horizontal is y equals 5.
Wait, what were they for the first one?
The vertical asymptote is negative 2, because what would make the denominator 0? A negative 2. And the horizontal asymptote is negative 9. So really, those asymptotes are in the equation.
Wait, are you trying to make it 0?
It cannot be 0. That's why it's an asymptote.
Yeah, but
it cannot. I'm sorry?
But the question said minus 9, so would it be plus 9? Would we make it 0?
Not on the horizontal asymptote. The vertical asymptote is where you're trying to make it 0.
Okay.
Only the vertical asymptote. The horizontal asymptote is actually a restatement of either of the translation up or down in a reciprocal one. Does that make sense?
Yes.
The vertical asymptote is the only one that you're trying to make that cannot be 0, because it would be in the denominator of a fraction, and that's not allowed. Okay? It makes sense or doesn't make sense yet?
Yeah, makes sense.
Okay. All right. So this one, vertically stretched by a factor of 4. That's going to be on the top. That's that A, which is on the top in the standard equation. Then it's translated right. There's no movement up or down, just translated right. So that's in a positive direction. So it actually looks like this. The vertical asymptote then is x equals 3. And the horizontal asymptote, since there's nothing there, is y equals 0, which is really the x-axis. Vertically stretched by a factor of 2 and reflected across the x-axis, right? So what happens? That 2 is going to become what?
Negative.
Good job. And then it's translated 1 unit left. So that's going in a negative direction. So that's going to be a minus minus, because the original equation for the denominator is x minus h. And if you do a minus minus, that turns into a plus. And then it's reflected, shifted up 8 units. So your vertical asymptote is x equals -1. Your horizontal asymptote is y equals, whoops, didn't mean to write a plus, equals 8. Okay, so now we're given the asymptotes only. So we're supposed to write an equation for this. So given the asymptotes only, we're just going to say everything else is going to be standard. Does that make sense to you?
Yeah.
Okay. So what do you think this one's going to be?
I don't know, but I'm having a bit of a problem with my sinuses.
Okay. X plus, because that's a minus, so x plus 7. So what I'm going to do first is set my vertical and horizontal asymptotes. So my vertical asymptote is whatever would make this 0. So that's going to be x equals 0. And my horizontal asymptote is that. So that's going to be y equals 3. And so what I do first, it's really ugly. My vertical asymptote is the y-axis because it's x equals 0. My horizontal asymptote is y equals 3. And so my domain, which goes with my vertical asymptote, is x such that x cannot be 0. And the range is y such that y cannot equal 3. It actually goes a little closer than that, sorry. It's just supposed to be a sketch. If you wanted it to be a little more exact, you could like you could do a T-chart 1. So that's going to be 1 plus 3, which is 4. So over 1, up 1, 2, 3, 4. I was trying to think of ones, and then -1, which would be like that. So this one's going to be reflected across the x-axis, and everything else is going to be the same, where the vertical is x equals 0 and the horizontal asymptotes are those. X such that x does not equal 0. Y such that y does not equal 0. And it'll just be reflected. So you see how it goes in the opposite direction. And I don't know, she may want you to do T-charts and that kind of thing. I'm asking that my kids really know where the asymptotes go. But did she say anything about wanting y'all to do T-charts?
I don't remember very much about that, no.
Okay. All right. Well, the vertical asymptote. I'm sorry?
Because I have my microphone off because I keep sneezing and stuff.
Oh, okay. That's fine. That's fine. Yeah. Don't worry about it. I understand if you're not feeling well, at least you showed up, right? There you go. So, bless your heart. I feel bad for you. Oh, and sorry about that. All right. So x equals or cannot equal 4, and y can. My. X, hi, how are you today? X equals 4 and y equals 0. And the domain is x such that x cannot equal 4 and y such that y cannot equal 0. So one, two, three, 4. Kind of the key to this is knowing that the hyperbola just follows the asymptotes. So you draw those dotted lines first for your asymptotes, and then your graph follows that. Does that make sense? And if I were doing these, I would be picking numbers that maybe like x equals 8. Which would give you 1/4. 6, which would give you 1/2. Things like that. Finn. To try and get points if she was having you do the T-charts to get more exact points. That's what I would do. So on this one, y equals -1 for your horizontal asymptote. And x equals -2. So the domain is all real numbers such that x cannot equal -2 because that would make that denominator a 0. And the range is all real numbers for y but y such that y cannot equal -1. So for x equals -2, and y equals -1. Oops. I actually know that's a point. The vertical asymptote for this one is x equals 0. And the horizontal is y equals -5. And for this one, y cannot equal -5. So you'll just place your asymptote lines 1, 2, 3, 4, 5 along there. And let's see, 2, that'd be 1. If I plugged in a 2 for x, give me 1. -5, that's going to be -4. So 1, 1, 2, 3. So we know that's a point on there. If you're trying to get some exact points, I just want to make sure that on a couple of these, I show you how to make a T-chart just in case she's expecting you to. And that way you'll have some examples. Does that make sense?
Yeah, it does. Just in a moment for copies.
Okay. Did I move too quickly on 9 and 10?
No.
Okay, good. And I hope that you're seeing as we're going along how the domains on the simple reciprocal ones really correspond to the vertical and horizontal asymptotes.
Yeah, I'm sorry I kind of stopped answering your questions.
No, it's okay. And I'm sorry if I, am quieter because I'm not really talking that much, but
Yeah, there was a Jehovah's Witness that knocked on the door, and I had to deal with that.
Oh, okay. Well, there you go. Did you get do I need to go back?
No, I'm
Did
good.
you get everything?
Yeah, I didn't answer the door.
Okay. Oh, okay. All right, cool. Okay, so x equals 6 on this one. So that's going to be the vertical asymptote for number 12. 1, 2, 3, 4, 5, 6. So your dotted line goes along here. And your horizontal asymptote is just your x-axis. It's y equals 0. We also note on this there's a negative, so it's going to be reflected across the x-axis, which means essentially instead of kind of corresponding to the first and third quadrants of the coordinate plane, it's going to correspond with the second and fourth. So it's going to look more like this. That's what the negative does. It reflects it.
These are the last two problems, right?
Yes, sir. So the vertical asymptote for this one is going to be x equals 1 because it's whatever makes that denominator 0. And the horizontal is going to be y equals -2. So once again, that domain corresponds to the vertical asymptote, saying that it's all real numbers except for x cannot equal 1. And the range corresponds to the horizontal asymptote. And this is just primarily for the reciprocal functions. We're going to be learning about some other functions later on where it gets a little more detailed than this. But for these simple ones, for sure, it corresponds to the vertical and horizontal asymptotes. And those are always the first things that you want to draw because it really helps in identifying the placement on the graph where it's going to be. And I forgot to mention, I'm really sorry, on this 2 up here on number 11, that would actually make it a little fatter and a little further away from the asymptotes. When there's a 1 up there, it actually, this is called a vertical stretch. So it's going to be pulled away from the asymptote a little quicker than if there were just a 1 up there. So that's going to be the case for number 13 and 14 as well.
Could you real quickly show me the graph for number 9? Okay, thanks. Let me get that down.
And it's kind of trying to graph a 1/4 and a 1/2 on these itty bitty graphs. Not easy. You know what I'm saying?
Yeah.
8, 7, 6. So like, that would be about, really my 1/4 and my 1/2 look virtually the same. So, just they're on there. Those points are on there. They just look pretty much the same. When your graph box is no bigger than a centimeter, it's a little difficult. But your y equals 2 asymptote, you draw that line in those are always dashed, and they really drive where this hyperbola is going to set. And then your vertical asymptote is x equals 1. This one is also going to be a vertical stretch. So it's actually going to be, even fatter. It's going to be going out a little more. So like, let's just take a look at that by doing this. Let's stick a 5 in because that's going to be pretty easy because 5 minus 1 is 4. So then I'm going to have 4 over 4, which is 1. And 1 minus 2 is a -1. So if I place that, I go over 1, 2, 3, 4, 5, and down 1. That's a placement there. And if I did a 9, that's going to be 9 minus 1, which would be 8. So that's going to make that 1/2. So 1/2 minus 2 is going to be 1.5, a negative 1.5. Right? Yeah. One, two, three, 4, 5, 6, 7, 8. Oh, 9 barely fits on there. So you can see that that's supposed to be nearing the y equals -2, and they even get smaller and smaller and smaller. But it's not going to be very close to that asymptote. I'm trying to think of another number. But this will be stretched. So the curve actually is supposed to be a little fatter, like, you know, not as pronounced. I'm not drawing it very well on here, but it's not supposed to be as pronounced. Like that versus that. Well, that wasn't even a very good comparison, but it's supposed to be a little fatter. And I'll show you what I did yesterday when working with a student. I'm going to jump on Desmos in just a little bit because it will show you a little better what the shrinking looks like. The vertical asymptote for this last one is x equals -5, y equals 4. And the domain, once again, corresponds to the vertical asymptote. And this is a -3, and it's going to be one of those little fatter ones. So it's stretched and reflects across the y. Let me know when you're done copying those. And just so that you can see a good picture of the difference between them, I'm going to draw 3 on Desmos because it's easier to see the reflections and the compressions if I do it on Desmos. And I really feel like you need to see that to understand this better. So let me know when you've finished.
I got it.
Okay. I am just going to do the regular. That's the regular reciprocal function. This is going to be number 12. So you can kind of see how it's reflected across. Oh, shoot. The red, well, I don't. The red is, oh man, bummer. The red is the regular. The blue, which now has an asymptote at 6, and it's also reflected across the reflected across the x-axis. So it's going the opposite way. And then this is going to be number 13. So you can see kind of how it's a little fatter. As a matter of fact, let me do something else. This isn't any of them, but I want to show you just if you compare this one with the red one, the purple versus the red, see how it stretches and it's further away from the X and the Y. And that's what I meant by that. It's like pushed away. But if you had this multiplied by multiplied by 1/2, which would be between 1 and 0, that's the black line. So literally thinking about the shrinking and the compression, the purple line is literally stretched, meaning that A, or the numerator, is larger than 1. So it's stretched and pulled away. The red is the normal reciprocal function, and then the black is the compressed, meaning it's pushed closer in and closer into the two asymptotes. So that's the vertical stretch and compression. So I wanted to give you a picture because it's so difficult to draw the graphs on those itty bitty graphs. So for you guys to really understand it and see it, I really do highly recommend using Desmos because it gives a better picture. And especially if you use the different colors on Desmos, you can kind of see how the shifting and the translating take effect of the overall equation. To me, the homework assignment where you're putting in the asymptotes, that's the best exercise for that. And then using Desmos to see the shrinking and stretching is the best exercise in really understanding how those shift. It also gives you some pretty clear points, too, for a table.
Well, thanks a lot for helping me.
Oh, hey, no problem. I'm glad to do it. Sorry you're not feeling well. Know exactly how to pray for you. I hope this really helped, and you have a good rest of the afternoon.
You too.
Bye-bye.